This is part 2 of our video series on percents. On the part 1 of our series, we worked on examples of this type, finding X% of a given quantity. In part 2, we're going to look at examples of the type, finding what percent of the whole a given quantity represents. So for instance, 100 is what percent of 200? Now this question is simple enough that we don't really need any fancy formulas. Well, hopefully we can figure this in our head. But I like simple examples because through those we can find the formula to the more complicated examples. So 100 is what percent of 200? Well, 100 is exactly half of 200, right? And a half means 50%. So we know the answer to this question should be 50%. But how would you do it so that you can then use the same method to do more complicated examples? And here's one approach. You can take 100 and you're trying to find what percent of 200 that is. So you're comparing against 200. So you're dividing it by 200. And that will give you 1/2, in other words, 0.5. So that's your decimal. But the question is what percent? They want to know the answer is a percent. So basically we multiply this by 100, so that moves the decimal 2 units to the right. So if you multiply this by 100, that will leave the answer in the percent format. So 0.5 times 100 is 50, and that is our answer in the percentage form. So it's important to note through this example, 1/2 or 0.5 as a decimal is equivalent to 50% in percentage form. So if you ever forget the mechanism, how this works, so going from a decimal to a percent, basically you need to multiply by 100. 0.5 became 50%. Going from a percent to a decimal, there 50% became 0.5. So there you're dividing by 100 basically. But no need to memorize this. If you ever forget, write down a simple example like this, and then you can recreate it and then go from there. Okay, similar question, numbers that are a little bit messier. 65 is what percent of 300? So we're going to compare 65 against 300. Again, this will give us a decimal. To leave it in percent form, we need to multiply it by 100. And that will give the answer in percent. So all we have to do is 65 times 100 over 300. Another way to simplify this is 100 goes into this once. 100 goes into this 3 times. So you can look at this as 65 times 1 over 3. And when you divide 65 by 3, you will get roughly 21.66. So roughly 21.7%. Another approach to do this question would have been to simplify that fraction first, which would give you 0.2166 and so forth, and then you multiply that by 100. So that gives you 21.66 roughly percent. And again, if you run into the nearest tenths, there you have the same answer, 21.7%. Okay, let's take a look at another example. In a group of students, there are 20 males and 10 females. What percentage of the students are females? So we're comparing the part to the whole. The part is 10 students, and the entire group consists of the sum of 20 plus 10, or 30 students. So the question is basically asking 10 is what percentage of 30? 10 is what percent of the total? So that will give us the results. But again, this will give us the decimal. To convert to a fraction, we're going to need to multiply it by 100, and that will give us the result in percentage form. So 10 over 30 is the same as 1/3, which is the same as 0.33 roughly. And multiplying it by 100 will give us the percentage, which is roughly 33%. And if you choose to take one more decimal, because this is really 33333 and so forth, you will get an answer of 33.3%. And typically, if it's not a units of measurement, there, of course, you go with significant figures. But if it's just something in terms of number of people and so forth, I think going to a whole number percent, or maybe go to the nearest tenths of a percent, I think those are usually commonly used values. Okay, we have a similar question here. In a group of 75 students, we have data on what major each student has selected. Determine the percentage of students who are majoring in education. As a matter of fact, do the same for each of the given majors. So find what percent of the whole are education majors, what percent of the whole are chemistry majors, and so forth. Do it for all of them. Now, for a question like this, first step is to find the total number of students in a group. But in the situation, they actually gave us the total. They said the sum of all these students is 75. And if you're adding this by hand, I think it would help to have that written in the correct location. So you can just double check everything, add it by hand, and make sure that you're getting 75 students total. Now, to find what percentage of the students are education majors, what we want to know is 25 compared to the whole, the entire group. What percentage does that make? This will give us a fraction or the decimal, and then we need to multiply it by 100 to convert it to a percent. In this situation, 25 over 75 is 1/3, which we just did an example like that. That's 0.333 and so forth times 100. So that will give us 33% again, or 33.3%. Let's round everything to the nearest tens for this question. Now let me give you guys a moment to complete the question. Please pause the video here for a moment, and when you come back, you will be able to check the answers. And here are the answers to the remaining parts. What percent of the entire group are made up of by chemistry majors? So that would be 20 divided by the total number of people in the group times 100%. So you get a decimal by doing 20 over 75 multiplied by 100, and we'll get about 26.7%. Do this for all the different categories, all the different majors, and you'll get the percentages for each group. And if you were to add all these percentages, what would you get? That should give you the entire group, right? That should be 100%. And it will be if you check your answer. Okay, another example, this time from chemistry. So we have a chemical compound. It's given that is made out of 12 grams of oxygen, 23 grams of nitrogen, and 15 grams of carbon. Determine what percent of the mass of this compound is made up of nitrogen. You see how similar this question is to the last problem? For the last problem, the first thing you had to know was what is the total number of people in the group. Here, the first thing that we need to know is the total number of mass for this compound. So, assuming it's made up of only these three elements, let's go ahead and add up those quantities to find the total mass for the given quantity. So we have 12 plus 23 plus 15. And 12 grams represents the mass of oxygen. This one represents mass for nitrogen. And the last one represents the mass for carbon. So if we just add those up, so we're getting 50 grams total for the compound. The question is, what percentage of this is made up of nitrogen? So you're comparing nitrogen to the grand total. So we're going to compare 23 to 50, and to leave it as a percent, we're going to multiply it by 100, and it will be left. This is just going to be a percentage, so let's just simplify it. Again, there's a number of ways you could get a decimal, then multiply it by 100. But I can't resist, there's a nice simplification to be done here. 50 goes into 100 2 times, right? And then 2 times 23 is 46. So the answer is then 46%. Again, so we took the fraction of the given part to the grand total, multiplied by 100. That gives you the percentage of the given portion in the entire quantity. So that means there is 46% nitrogen in this compound. And if you did it the other way, first do 23 divided by 50, then you will get 0.46, and then multiply it by 100, and that will give you the answer as a percent, which will still be 46%. Okay, next example, very similar one. So the question is, find the percent composition by mass of acetaminophen, which has the complicated looking formula there, which I'm sure you guys are gonna learn in your chemistry classes. Given that 1 mole of the substance contains roughly 96 grams of carbon, roughly 9 grams of hydrogen, 14 grams of nitrogen, and 32 grams of oxygen. So the question is, find the percent composition by mass. That means find, for each of these elements, find out what percent they make up of this given substance. So starting with carbon, if it's 96.08 grams, what percent of the entire substance is carbon? So I'm going to give you a moment. If you would please pause the video, try it on your own, and come back and check your answers. Here's the answer. The first thing we do is to find the total mass for the substance, for 1 mole of the substance. Since we're given that carbon contributes to this substance as 96.08 grams and hydrogen as 9.09 grams and so forth. If you add all of that, you'll find the total mass of the substance. Now, as a matter of fact, in your chemistry classes, you will learn how to come up with these numbers by looking at a periodic table and realizing you have C sub 8. That means you have 8 carbon atoms, so you multiply things by 8. But right now, to make things easy for you guys, because this is not necessarily a chemistry video, rather it's helping you in chemistry, but concentrating on percentages. So here we actually provided the values, so you don't have to come up with those numbers. So all we have to do is we have to add them up and come up with the total amount for 1 mole of the substance, and that is 151.18 grams. And our job is to determine what percent of that is carbon. Since carbon is 96.08 grams, we just take a ratio like we've been doing all along, right? So you do 96.08 divided by 151.18, and you multiply it by 100 to leave it in percentage form. And that's what we get. About 63% of the substance, or 63.55%, is made up of carbon. What about hydrogen? So you do something very similar. I'm going to let you guys do that if you haven't already done so, and please come back and check your answers. So 9.09 over 151.18 times 100. So that gives you the percentage mass composition of hydrogen. Do the same for nitrogen and oxygen. And if you add up all these numbers for checking process, you should be able to get 100%. Here's our last example, once again an application from chemistry. And you may have also seen examples like this in your intermediate algebra or college algebra classes, your typical mixture problems, right? So you have 40 milliliters of a 5% hydrochloric acid solution that is mixed with 10 milliliters of an 80% hydrochloric acid solution. What is the percentage concentration by volume of the resulting mixture? So first, because it says everything's in terms of by volume, let's go ahead and find the actual amount of hydrochloric acid by volume in the first solution. So for that, we need to take 5% of 40. So I'm going to take 0.05 times 40 milliliters. Plus, the exact amount of hydrochloric acid in the second solution is 80% of 10. Again, we learned it in the first video. To take 80% of something, you take 0.80 multiplied by the quantity times 10. You could certainly do 80 over 100 and 5 over 100 if you prefer to use the fractional formats. So that should give us the total amount of hydrochloric acid in the final solution. So if you multiply that times that, you will get 2 milliliters. And both of those had one significant figure, so my final answer has one significant figure. And here 0.80 times 10 is going to be 8 milliliters, again with one significant figures. And the answer is 10 milliliters. And this is 10 milliliters of hydrochloric acid in the final solution. So if you have 10 milliliters of hydrochloric acid in a 50 milliliter solution, the question is what percentage solution that is. So that is the second type of problem that we have been doing. So you take the existing amount, the part of the whole, and you divide it by the total to find a percent. And don't forget to multiply it by 100, right? Otherwise you'll have a decimal. So multiply it by 100. So here we have really 10 over 50 is same as 1 over 5, which is 0.20. Of course, you could use a calculator if you need to, but 0.20 times 100% gives us 20%. So we're saying that the final mixture will be 50 milliliters of a 20% hydrochloric acid solution. So I hope that these two videos were helpful in reminding you about basic concepts involving percentages.